you up. But some of the topic was completely not helpful, as in the coronavirus. What was helpful is that I was going over the example that they started yesterday. I started in the beginning with the, wait guys, what's this?
Ratio.
The ratio test. Okay, good. Good. Okay, so we have the ratio test, right? And then we figured out that we have, this is our interval of convergence. Why do we have two little baby question marks? We have to check the endpoints, and thinking about the AP and how they love to trick us, are they going to give us probably an answer where both of these are open?
Yes.
As the final answer?
Yes.
No, because couldn't you answer, okay, wouldn't your brain want to choose this as an answer right away?
Yes.
And maybe forget this whole process? So they're going to make it the non-answer because that's what your brain will naturally do.
I thought you were saying that would be one of the options.
Yeah. Oh, got it. Yes, they will make it an answer, but will they make it the answer?
No.
Okay. So then, thank you all. We need to go ahead and make sure that we know to double check those endpoints because we need to be ready for however tricky they're going to be. So we were double checking at 3, and as we double checked at 3, we realized some funny stuff was going on with signs, and we were able to use like properties of exponents, right? To get the n plus n to be a 2n. And what did we notice with this guy when we started actually plugging in? What happened with every single guy? Did it alternate?
Negative.
They were all negative. So what am I able to do if they're all negative? Take it out and then deal with the positive guy and be like, oh, stink, what does 1 over n do? So since he diverges, are we going to include the 3? No, but why did we just go on a whole tangent, a whole spiel for like an extra 5 minutes, even though it was obvious, it was easy, it was divergent, and we say don't include it? What did some of you think it was yesterday because you didn't realize that the -1 actually was with every term and could be factored out? What did you think this was? Oh, I was thinking more alternating. I had at least one person come up and talk to me. I think others of you, well, you thought for a second. It was alternating. Is it alternating? But if it was alternating, what kind of convergence would it have had? Conditional convergence. And Dean and Gavin, here's what I asked them that I got worried about, and so we had to stop and talk. I asked them, is conditional convergence valid convergence? And they pretty much unanimously, of those that actually answered, said no. And I said, wasn't very loud and forceful. Of those that I heard lots of no's, and I just stared, and I kept staring, and you guys just stared back, and I said, okay. Anyway, so then I went back over David's SAT example of if you mark Hispanic on the SAT, there might be a pop-up screen that says, okay, but what kind? Meaning, where did it come from? What is your heritage? Specifically, what type of Hispanic? And so that's what I brought in, saying, wait a minute, are you still Hispanic even if you mark something like Spanish or Latina, Latino, etc.? And they said, oh, we're wrong. At least Janelle did. Yeah. Because she noticed the adjective did not take away the validity of the original statement of, well, Hispanic, but in this example of convergence. So if this had been alternating, if it had been conditionally convergent, would you have included the endpoint? And the answer should be now. Yes. Because it is convergent. Okay, what have we not done yet? 7. Do you see how every single one of these interval of convergence problems technically has 2 convergent divergent tests along with it? So we have this whole interval ratio test, and then we have 2 different other convergence to figure out. Maybe it's fast, maybe it's not. Lorenzo, what's up as I go ahead and set this up?
Do they have to show work for testing the endpoint?
Oh, on the AP, yeah. Because if you are answering an interval of convergence FRQ and you don't show the analysis of the test point, it's like answering an absolute max question without showing the testing of the critical numbers and the endpoints. And remember, the AP was so sneaky that even if it's a relative min and you're looking for a relative max, if you don't test all the critical numbers and endpoints, they will take it. So if they're that picky on extrema, they're going to be that picky for sure on intervals of convergence.
How about for you? For your test?
What are my tests supposed to be preparing you for?
Exam.
And did some of you make a quick mental mistake even if you wrote out the work on this one yesterday? Yes. Do I need you to write it out and make sure you're good? Yes. Do I need a full paragraph of information? But I need enough to show that you tested it and that you know why you are or are not including it. Meaning, I need to know convergent or divergent with the test. Cool? But the work should be able to show me. And if, hold on, what am I thinking of as far as a Calc AB topic? What's the one where the work basically explains it for itself? Absolute extrema was 1 as long as you plug it into a table, but it's better if you state it in words. Second derivative test, but you should still state that in words too. You don't have to necessarily state in words, but you do need to show the analysis, and the analysis does need to show the correct application of a test. Okay. So as we go ahead and plug in, sorry, that's not a 7, that's a -1 raised to the n plus 1. When we plug in, what are we plugging in? 7? 7 minus 2 is 2 to the n?
So minus 5 is 2 to the 1.
Wait, is there something else up here? Is there an n? No. Okay. All over n 2 to the n. Hey! What do we get to do with the 2 to the n's?
Reduce.
Ah! What's going on with the -1 to the n plus 1? It's alternating. Wait a minute. So this one wasn't conditionally convergent. I should have just waited and had this whole discussion over here. But now you guys are going to get it right, right? Because what can we say about this guy? This is conditionally convergent. Now hold on. Lorenzo's trying to show as little work as possible. So how do we show it's conditionally convergent? Being complete and yet concise. Why is it conditionally convergent? What? The limit is 0 and the terms are decreasing. Are we okay? Yes. Is that enough?
Yes.
Yes. Two things that need to be true, right? The limit of the absolute value, which is why I just looked at 1 over n. And then the terms need to decrease. So since both of those are true, conditionally convergent, what does that mean? Convergent. And since it's convergent, what am I going to do? Include. And since I'm including, Lorenzo's kind of trying to tell me how. I'm going to think of it as 3. Oops. Nope. 3 less than x less than or equal to 7, or another way of writing it is x is within the open interval 3 to 7 close. Dun, 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 dun. Wait, what's the radius?
2.
Wow. Why is the radius 2? Wait, where was this original guy centered? No.
Oh, 5.
It was x minus 5. This is centered at 5. So how far from 5 am I allowed to go out and still have convergence? 2 to get to 3 and 2 to get to 7. Oh, that makes sense. Dun, 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 dun.
That's a lot of work for a letter A.
Well, let's just say this wasn't like a letter A of an FRQ. This would be more like an AB. See? Maybe an AB. Okay, you guys don't necessarily need, I don't think, me to walk through this other one necessarily. I did show you the solution to it yesterday, so some of you are bored because you're like, I already got the right answer. I'm amazing. Others of you are like, I didn't even try it. So to get us all back on the same page, let's go ahead and go find a new one. What do you guys want to try? We don't have to do every single one, but I do want us to practice.
I'm joking. Yes, all
homework.
I'm not joking.
What do you want us to try?
D.
D? All right. C?
No, D.
All right, I heard more D's. Let's go for D.
D.
You're lame.
Dean, which one do you want?
Alright, so for right now, we're saving C off to the side. We're looking at D. As we look at D, where do we start?
Looking for
Gavin.
Dean.
We're going back to C?
No, you said
Love you,
yes.
Gavin.
What are you
doing?
We're
D,
doing
D for Dean, C for
doing D
Gav,
right now.
We're doing D.
Good job. C for Gavin.
Gavin.
How do I start?
Do it.
Okay, get ahead of me. Get ahead of me. You can walk me through the entire process. So get ahead of me. Show me that you know. Show yourself that you know how to do the ratio test.
Yes, we're doing D. Thanks.
You're welcome.
Are you doing the n plus first over the n?
No.
Oh, you better
That was
Oh, okay. So we're doing
How are we doing this?
Or is that one test?
like one or
So
two.
it's for
The
some
Oh,
ratio?
yes. It's kind of
Or is
different.
it
So we're
one
practicing.
So
plus
do you
this?
You
gonna start coming behind, but check in with each other. If you're like, I got this,
Oh, that's 3.
check in.
Plus 1.
Make sure your group
Is
has
it
got
n
it
plus
as
or is
well.
it n minus 1? Okay.
The n plus first over the n.
3 should be fine.
Yeah, I think
So
it's
it's n
times
plus 1
n
factorial
factorial
times
what?
x
X.
n plus 3
So
And
n and then
that cancels out. That keeps
and
the
you can
n.
multiply it by
Yes, I
1
think
over
you have. I have a few of you that haven't paid for shirts yet.
1 over
Uh-oh,
n
losers.
factorial
Patricia, David, Kyrie, you owe me at some point.
X minus
Just reminding you.
all over
You want to know the totals?
n.
Just in case you forgot.
so do you have the
Yeah, me?
Okay, hold
Long
on.
sleeve,
I got
n
24.
plus 1 times x minus
n
3?
plus 1 times n plus 3.
Short sleeve,
Now what? Is the limit of it?
The factorial.
19. Nope,
Yeah,
18.
1
Only
over
18,
the
Patricia.
Okay.
Kyrie, 32.
Oh,
Is it like x no change?
there you go.
Yeah, no change.
yeah.
Nice and even.
506.
I mean, I had change for you, but yeah, no
And
sense.
the n factorial cancels out with that factorial.
Okay,
It's
just
just
n plus 1?
and then
Infinity.
x minus 3.
But that's not the
So
reciprocal.
we
Times
got
x
reciprocal.
No, because it's supposed to be n plus
So it's infinity.
n plus 1.
So
So you
divergence?
replace n plus 1 with that.
Oh, I
I'm
see.
sorry, I didn't check. There we go.
No, it has
There.
to be 3. It still needs
Less
like
than
100.
1.
Oh, I forgot to write that.
Because then
I should hear her rambling. I don't know what she's saying. Is anybody confused?
No.
Don't wait.
I got to that point.
Is anybody confused?
I don't know that
Okay,
one.
wait.
How does that
I
one?
plug in infinity. What's
Infinity?
it going to?
Infinity.
Infinity.
Is infinity ever less than 1?
Yes.
If
It's greater
x
than
minus 3 equals to 0.
AJ.
Is it less than 1?
No.
So therefore,
It's 0.
Wait, it's the
Never.
if x
Never.
equals to 0.
shut up. Is infinity less than 1?
No.
No.
Okay, so hold on. If it's never, now we're in a bit of a dilemma because do we have an interval? The answer is no. The answer is no. Infinity is not less than 1, so we don't have an interval. However, I have a question for you. This is a power series, right? And a power series is centered at a certain point, right? Isn't a tangent line centered at a certain point as well?
Yes.
Okay, so tangent lines. How many points do they meet the curve in the local vicinity that it's at? 1, because it skims. So as soon as you go away from the point, the tangent line starts to diverge, right? The tangent line can't follow the curve. Power series can, as long as they're convergent power series. Power series can converge to curves, but tangent lines can't. But question, even though tangent lines diverge from the curve for every point for all values of x, where does the tangent line still hit the curve perfectly? At the point. What am I trying to say? There is no interval. But Lorenzo just said, wait a minute, what about at x equals 3? What about at x equals 3? What would 3 minus 3 be? 0. Now I'm not going to go multiplying 0 times infinity and indeterminate. We're not doing that. But what we are saying is, wait a minute, this power series is centered at 3. What does that mean? Where do I have convergence automatically because of where it's centered and where it's hitting? At 3. What I'm looking for is there any interval, is there any radius, is there any length of space or x values where this will converge, not just at the point, but somewhere else. So if there is no interval, if there is no distance I can move, I can say the radius is equal to 0. But even though the radius is equal to 0, even though I can't go away from the point, where will convergence still be?
You put 2.
Oh, sorry, I meant 0.
Oh, what?
Why did I put 2? No. Since the radius, because that was the last one. Since the radius is 0, I can't move off the point. Where will I still be convergent? It will only be convergent at x equals 3. There is no interval.
Oh.
There is no interval.
Wait
The
a
limit is
minute.
infinity. There is no interval. I
The
can't
reason
go
zero-
off 3 and have it still be converging, but I can still be at 3. I can't be off 3 and still converging, but I can still be at 3 because this power series is centered at 3, which means at 3, like a tangent line, similar to a tangent line, there will be convergence. Yeah.
There is no
When we
interval in
see
the
a
range.
series that we know that it diverges, can we just say it's only converging at that point by using other test than the
Lorenzo's looking at the initial expression and seeing that the limit by the nth term by the divergence test. This is a divergent series. So he's like, how can a divergent series converge? Because the limit is not 0, therefore divergent.
So can
If the limit is 0, we know nothing, just reminding them of the divergence test. I believe that's a valid conclusion. I believe that's a valid conclusion. So that one didn't take as long as you guys thought, huh?
C.
Because we don't have endpoints. We don't have to test endpoints. I think so.
What's D?
So maybe we will go back to C, as in we should try part C. As I answer AJ's question, go tackle C. Yeah.
So because there's no interval, then it converges around the.
It doesn't converge around the point at all, but it still converges at the point. Like a tangent line, it meets, but as soon as you go off, it's going to start diverging. Does that kind of make sense?
Wait, what?
So the tangent line meets in one point, right? But then as soon as you get to that point, as soon as you go off, it's going to start diverging from the actual. That's kind of what's going on here in that if there's no interval of convergence, I can't go away from the point and have it keep converging, but it still works at that point. And where is that point? X minus 3 tells me this whole thing is centered around 3. Does that make sense?
Yeah.
As you guys are playing with the next one, where's this one centered around? It's in McLaurin. Yeah, centered around 0, right? Because it's x minus 0. I'm going to start playing if you guys don't mind. Remember, the n plus first over the n, the absolute value lets us ignore the alternator, yeah?
Yeah.
Are you guys getting 2n plus 3 when you plug in?
So I plus wait, what?
Over 2n plus 3 factorial?
Isn't it?
Hold on.
Wait, why?
2
Oh,
times
because
n
it's
plus
n
1,
plus
the 2
1.
has to distribute.
Yes.
2 times n plus 1.
Oh.
2n plus 2 plus 1. See it?
Yeah. And it's the same for
Because
the
already
top.
n plus 1.
Because it's 2 times n plus 1, so 2n plus 2 plus 1.
Gotcha.
This is going to make simplifying be a little bit more interesting, right? I got rid of my absolute values because I already took it. I got rid of my alternator. But do you guys see why it's 2n plus 3? Did you plug in that n plus 1? Did you distribute? Are you thinking how to simplify? Now I'm throwing back in my absolute value, not for sake of the n's, but for sake of the x's. Remember, they're still kind of like, well, you could be positive or negative x's. I don't know. Why am I going to write this 2n plus 3 times 2n plus 2?
Because it's the next
Oh, it's a
term.
factorial.
I'm going to go from 1 all the way up to 2n plus 1. But guys, what would the next term be from 2n plus 1? 2n plus 2. And the next one? 2n plus 3, 2n plus 4. He has 2 extra terms. And this one, when I go simplifying the 2n, because remember it's x to the 2n times x cubed, x to the 2n times x. Now I have an x cubed over an x. That's going to be an x squared up top. And that's what's going to be less than 1. Now hold on, I need to go ahead and figure out my limit. So what if I rewrite this a little bit? And what if I say, wait a minute, you guys are the ones I have to take the limit of. You guys are the ones that don't need to be in the absolute values because you're always positive. Those always positive people. I mean.
Okay, Misty. Thank you.
Ooh!
Some of my best friends are those always positive people.
It's gone.
Doctor Lasagna.
The problem's gone.
The original function.
Okay, how we doing? Does it make sense? The ends are always positive, no big deal. They have to come outside the absolute value. Wait a minute. What's the limit of this? 0. So wait, if that's going to 0, like this is going to infinity, hold on, what's 0 times anything?
Zero.
Oh my goodness, and how often is 0 less than 1?
Every time.
Which means the radius of my convergence is infinity, it's infinite, which means I can go forever from my 0 to the right or forever from my 0 to the left. This infinite series, sorry, the one that's way up here. Oh, it really did
No,
disappear.
you
Where'd it go?
swiped it away. You were trying to move it. So it's up somewhere.
It's just in left.
Where'd it go?
Somewhere. You like swiped it.
Oh, there it is. I didn't know what she meant. I just heard that the problem was gone. I was like, no, it's not.
She was like, it left.
Okay. Wait a minute. So, the radius is infinite because this is always true, regardless of whatever x is. As this goes to 0, well, then that one that's going to be just fine. Of the infinite series. So, what's my interval of convergence?
Infinite.
No, that's not an
All
interval.
real number.
Nope, that's not an interval.
No numbers.
From negative infinity to
Oh, that's an interval.
Got it.
So we saw one that has none, but be careful, the none still has one.
It's G.
But we also saw one. It's okay, I got the G, V, T. I haven't gotten the T much, but
There's so many.
I know it used to just be me.
No, I said the none and then Jesus.
Jesus. What?
E for effort. All right.
0 for effort.
You guys ready for homework?
Yes, let's do homework.
Yes, that's the whole.
Taylor series. Okay, we heard both of you.
Last night? Not last night. Monday.
So what are the things like the AP ask us? I mean, you guys can be getting out of Google Classroom. You can be writing down the homework. It's fine. I don't mind. You should have already started it anyway. Awkward. However,
No group.
ooh. Okay, this one. Wait, pause. This one looks pretty straightforward, right?
Yes.
Because if you know your Endeavor card, if you know your Endeavor card, you should be able to know this guy's power series, right?
X squared.
X squared.
And what would you see as soon as you? Yeah, some of you were just like.
Everyone was going too fast for me.
What about that 5x?
Just throw that baby in.
Oh yeah, throw that puppy in, right? You can just like get it. The general term is a little bit harder. Remember, the AP loves to ask for the general term, not all the time. Like, you guys realize there are only so many Taylor-Maclaurin series questions. Wait, didn't we have a practice exam recently? A practice BC exam where you were able to skip some questions?
Yes.
You hadn't seen them yet?
Oh.
Were some of them Taylor-Maclaurin series with little sigmas?
I remember Taylor.
I remember Misty.
Yeah, it was a
Oh, I
thing.
remember that.
Anyway, we'll get back to that one of these days. But for right now, the general term would be helpful if you had your forever card. Okay, but that's pretty straightforward. Pretty straightforward, right? What about this guy?
No, Misty.
The last one was censored at
Yeah,
X
X
equals
equals 2.
So what does that mean?
I was going to do that, but I skipped it.
Can I use my special endeavor?
No.
No.
Thank you, Joe. Saves me from having to come back.
Great.
So, what are we gonna do?
Use the formula.
Use the formula, that's a thing. Why am I allowed to put equals? Because I'm going to have a plus dot dot dot, and e to the x converges for all real numbers of x, as we've kind of already seen. But aren't I going to have to think about something like f of 2 plus f prime of 2 all over 1 factorial? I mean, that's not that big a deal. X minus 2. How many terms am I supposed to keep? First 4. Now, thinking on 0, but I'm not sure these ones are necessarily going to have a lot of zeros, so maybe it's not that big a deal. Oops. Don't forget your. Okay, well, we're going to have to get there. But we're going to have our f to the nth derivative of 2 all over n factorial all times x minus 2 to the n. Okay. But what are we going to have to do to actually find this? Yeah, that's the problem. In my special Maclaurens, my derivatives at 0 all end up being 1 because it's e to the u, e to the u, e to the u, plug in 0, it's 1. But as soon as I have something other than 1, oh, is it going to be tricky on the AP when they give you stuff centered somewhere else? Or maybe even on the test itself? Because then you're going to have to actually think of, oh man, what's f of 2? What's f prime of 2? Well, isn't it going to be 5 times e to the 5 times 2? Whereas this one was e to the 5 times 2? Aww, is this going to get messy?
Yes.
Okay, now we've at least, thank you, Joe, gotten the proper approach to that one. What about this one? Is he Maclaurin?
Yes.
Oh yeah, because it's just x, so it's x minus 0. And it's given to us, so we know it's centered around 0. What are they saying about f prime of x and f prime of 0? How do we find f prime of x of a power series?
Centrum equals to the
F prime of x though? F prime of 0, Lorenzo's trying to be like, hey, I think f prime of 0 is in there somewhere, let's go find him. But f prime of x, can't we just derive it?
yeah.
So what's the derivative of 1?
0.
What's the derivative of x?
1.
Keep going.
2.
2x over 2 factorial, I mean, I think that simplifies, plus 3x squared all over 3 factorial, plus 4x cubed over 4 factorial. They don't tell us that the general term, but guys, what happens when you reduce this? That'd be 1 plus
It's the same thing as
x over 1 plus, doesn't the 3 reduce and you have 2 factorial?
It's the same.
Who is this guy?
e to the x.
Does it make sense that the derivative would be the exact same as the original?
Yes.
Do you need to know your Endeavor card in order to be able to make that match? I think so. What would f prime of 0 be? Lorenzo. Let's use what you were saying, just because they don't always ask for f prime. They might ask for the 10th derivative, and we don't really want to take the 10th derivative. Well, of e, I guess we could. But to find the derivative, don't we look at this term and spotlight him?
Yep.
And don't we think about how he came from f prime of 0 times x minus 0 all over, I guess, 1 factorial?
What?
It's kind of boring. But we could set f prime of 0 all over 1 factorial equal to the coefficient of x, which is 1, and then we could solve. It's kind of silly. I know. It's way more exciting in other problems, but
I mean, like,
there we go. Long story short, do you guys need to do some more work on 10.4, 10.5 to get us ready for some more practice, getting ready for the test? Ooh, some more recognizing familiar functions and then deriving Maclaurins and then, oh, okay. This is where the creative thing comes in that we've already kind of played with, but we might go ahead and double check if there's any other creativity that's required for some of the other problems that they might ask. If you guys notice, they start bringing in, yes, the special Maclaurins, but then also other stuff that we've already kind of dealt with to some extent back in section 10.1. But anyway, we'll keep playing, we'll keep practicing, we'll keep, multiple choice. It's coming. Oh, that one's fun. I'll just leave this one on the screen for you guys to ponder. You can be pondering this one, you can be getting out your Google Classroom and writing down your homework that is due tomorrow. But tomorrow is Thursday. What else is on our calendar? I know we have an AP packet that I want us to work with. Let me look at your calendar and see what else there is. I'm just seeing if I can make it like tomorrow midnight instead of tomorrow tomorrow morning.
Like midnight into Friday? Like tomorrow midnight instead of tomorrow 8 a.m.
What do I have?
Wait, tomorrow.
Chapter 10 review, the AP packet we'll be working on tomorrow. Chapter 10 review.
Something tomorrow midnight. It could be like midnight to Thursday. Okay.
Alright, keep an eye on Google Classroom. Keep an eye on Google Classroom. I will see if I can make it any longer. Lizzie, I'm gonna go to work. Alright, have fun at work.
Have fun at work.
No.
Okay.
I work for Bob.
What is Harris?
Wait a minute.
Gavin, how y'all doing?
Oh, he's not gonna get to watch it today though. There's a student council meeting.
Oh,
He still watches it though. He'll catch up.
Hi, Gavin. Oh,
The what one? Yeah, but the first name is, yeah. Jacob, are you writing down the homework?
Alright guys, since today is a Wednesday, here's what I'm gonna do. Tomorrow is gonna mostly be a work day and a mostly structured work day. In that, I'm gonna give you an AP packet on chapter 10. I'm gonna be having you play on reviewing, but depending on your life, you might be finishing up homework as well. Yeah? So I'm going to go ahead and make the homework due tomorrow by midnight. The reason I'm having it due tomorrow by midnight and not Friday morning is because you should be finishing it in class, not starting it. Finishing it in class, getting it in by the end of the day so that you can then focus on AP packet / test review Friday and over the weekend to get us ready for that test on Tuesday. Sound good? Yeah. I'll go change that deadline.
Thanks, Christine. You're the best.
Huh.
I'm not gonna be here on Tuesday.
Why not?
I'm going to take my driving test.
Oh, you already told me that.
Garrett.
Wednesday. There's a difference between physically tired and mentally tired.
I don't mind.
Hi, Dean. That's why.
Yeah.
Go a little faster.